All right, so we all know AI can do some pretty amazing things, but what happens when it gets, well, stuck? That's what we're digging into today in The Explainer, a really cool breakthrough in teaching AI how to think its way out of confusion.
So yeah, that's really the big question, isn't it? When an AI just hits a wall, gets totally confused, how do you teach it? How do you get that artificial brain to handle its own uncertainty and, find the right way to go? This is a huge deal if we want to make AI genuinely useful.
You see, the goalposts have moved. We're way past just building chatbots that can answer basic questions. The real dream now is to create what researchers are calling AI agents. And these are systems that can actually go out and tackle complex, messy, real-world problems all on their own.
So what is an AI agent? I love this analogy. Think of it like an AI with a tool belt. It doesn't just think, it acts. It can grab a tool, like a search engine, to check a fact, or maybe a code interpreter to run some numbers. It uses all these tools as part of a bigger plan to get a tough job done.
Okay, so to really get why this new idea is such a big deal, we gotta first look at how we used to train these agents. The old way, which was all about judging the entire journey from start to finish.
So traditionally, training an AI agent was kind of like judging a marathon by only looking at who crossed the finish line. That's the old way. It's called a trajectory-level approach. Basically, you look at the whole path and only care if the final answer is right. But think about it. That misses how the AI actually ran the race, right? And that's where this new idea comes into play. It zooms in on the how, the critical steps along the journey.
And yeah, that's the big, glaring flaw, isn't it? When you only grade the final answer, you miss all the important stuff in the middle. You completely miss the exact moment the AI made a genius move, or the moment it went completely off the rails. It's like your math teacher only looking at the final answer and ignoring all your work. You'd never learn what you did wrong or right. But this is where it gets interesting. By digging in and looking closer at how these agents actually work, researchers found a really critical clue. And it was hiding in plain sight, right inside the AI's own moments of confusion.
What they saw was this weird but super consistent pattern. It happened like clockwork. Every single time an AI agent would pause its own thinking to go use one of its tools, like hitting up a search engine to find some new info.
And this observation from the researchers just nails it. They found that these models, and this is a quote, tend to exhibit highly uncertain behavior immediately following interactions with external tools. That was the light bulb moment. The AI's confusion wasn't just random noise. It was predictable. Now, this uncertain behavior isn't just a feeling. You can actually measure it. It's called token entropy. The easiest way to think about it is like a confusion meter for the AI. When the AI is super sure about what word it should say next, its entropy is low. But when it's confused, juggling a ton of different options, its entropy just spikes. And look at this chart. This is the smoking gun right here. You can see that before the AI uses a tool, its confusion level is pretty low. But check out what happens right after it gets that new info from the tool. Boom! A huge spike in uncertainty. It's like the AI is literally saying, whoa, okay, I just got a bunch of new stuff to think about. And this happens every single time. So if this spike in confusion is a predictable signal, well, then you can use it, right? You can use it for training. And that exact idea led to a brand new algorithm. It's called Agentic Reinforced Policy Optimization, or much easier to say, ARPO. So what ARPO does is pretty brilliant in its simplicity. It's designed to zoom in and pay super close attention to those specific moments of high confusion, those predictable spikes that happen right after the AI gets new information. So here's how it works. Let's imagine our AI is a smart explorer on a journey. First, it starts trying to solve the problem. Then, it hits a point where it needs more info, so it uses a tool like a search. Now, this is where ARPO comes in. It sees that spike in confusion and basically tells the AI, whoa, hold on, this is a critical fork in the road. Send out some scouts. So the AI quickly explores a few different reasoning paths from that exact spot, figures out which one looks best, and then commits to that path. It turns a moment of being lost into a smart, focused exploration. Okay, so the big question, does it work?
Does teaching an AI to embrace its confusion actually make it better? Well, the results are kind of shocking, actually, in a good way. Let's just look at the data. They tested this on something called the GIA benchmark. It's full of really tough problems that require deep searching. A model trained the standard way got a score of about 37. Not bad. But that same model, trained with ARNPO, its score jumped all the way up to almost 44. That is a massive leap in performance on a seriously hard test.
But that's not even the most impressive part. It's not just that ARPO makes the AI smarter. It makes it way, way more efficient. Get ready for this. ARPO gets these better results using only half the resources. Half! That means it's twice as efficient. Because it's not just wandering around blindly, it's saving all its heavy thinking for those critical moments of confusion. It wastes way less time and energy. And that, my friends, is a huge deal for actually being able to build and run these powerful AI agents in the real world without breaking the bank.
Okay, so let's zoom out. What does this all mean for the big picture? For the future of AI?
All right, so what are the big takeaways here? Number one, AI agents get confused. They show that high entropy spike right after they use a tool. Number two, and this is the key, this confusion isn't a bug, it's a feature. It's a signal to learn. Number three, ARPO is the clever algorithm that teaches an AI to use that signal to explore its options. And the result? You get better, faster, and cheaper AI agents. This really could be a scalable path forward for building truly capable AI.
And that leaves us with one last big thought to chew on. We just saw how we can teach an AI to take a moment of pure confusion and turn it into a moment of strength. So if AIs can learn to navigate their own uncertainty, what human limitation will they learn to tackle next?